Hello students and parents, welcome to Concept Clarity, and today's topic is going to be about cross product. In the previous session we saw dot product. Today we are going to see cross product. Cross product is also called as a vector product. So let us understand this. We'll clear this slate. We'll see the next slate. So let us consider again here. We have two vectors A and we have a vector B, and the angle between them is theta. So vector or the cross product is written as A, as the name specified, it's a cross. So cross will come here. B. A cross B is given as AB sin theta with the unit vector. Okay, because it's a vector product, so you'll get a vector result here. In the dot product you'll get a scalar result. So this is read as A cross B. So what does the cross product give us? The cross product gives us another unit vector, and this unit vector is perpendicular to the plane of A vector and B vector. So if you want to imagine this, one vector is this way, another vector is this way. This is A vector, this is B vector. So the cross product will give us a third vector which is perpendicular to both of them, which is n cap. Okay, so cross product is going to give us another vector. It's going to give us another vector, and the speciality of that vector is it will be perpendicular. It will be perpendicular to the plane of A and B. So we can use the right hand thumb rule here to identify the third vector. So let us see how to use the rule. I will clear this out. So to find the direction of the third vector, we are going to use right hand thumb rule. Right hand thumb rule, right? So what we have, these two vectors we have here, A and this is B, right? So we want to find the cross product, A cross B. So we are moving from A to B. So this is my right hand, I am moving from A to B. So my thumb will give the direction of the third vector, which is upward. So n cap, which is the third vector, is upward. I hope this is clear. So A cross B is equal to AB sin theta n cap. Okay. I will clear this out. Let us take it to the next level of depth. We have a vector A and we have a vector B. Okay, and this is the theta angle between them. Now if I have to resolve the component of B into parallel and perpendicular to A, then what will I get? Into parallel and perpendicular to A, right? Perpendicular to A will be this vector. This will be B sin theta, right? And this will be B cos theta. Then the magnitude of the cross product is the area of the rectangle between vector A and the perpendicular component of B. What is it? Is the area of the rectangle between vector A, the area of the rectangle between vector A and the perpendicular component. This is the perpendicular component of vector B, which is equal to the area of the parallelogram formed by vectors A and B. Okay. So in a cross product, only the mutually perpendicular component of vector is important, whereas in the dot product, only the parallel component of the vector is important. So in a cross product, what is important? Only the mutually perpendicular component of vector is important. Okay. So the vector product of two vectors is always a vector. So let us see some properties. Properties of vector product. The first property, the vector product of two vectors is another vector which is perpendicular to the plane, and this we have already studied as a definition. So the vector product of two vectors is a third vector, and this third vector is perpendicular to the plane of these two vectors. Okay, and this we have seen it like this, right? Right hand thumb rule upward. This was n cap, and this is what is A cross B. This is what is A cross B. Okay. Vector product of two vectors is not commutative. The second property is vector product is not commutative. That means, what does that mean? A cross B is not equal to B cross A. Okay. So because when you do A cross B, why? As per the right hand thumb rule, when you do A cross B, the third vector is upward, right? If this was A and this was B, then the third vector is upward. Now if you do from B to A, if you do B cross A, then my thumb will point downwards, right? B cross A, the unit vector will form downwards, right? So that's why they are not equal. Okay, these are some of the properties. These are two properties. We'll see the third property. I'll clear this, or should I write it here? I'll write it here. It is vector product is distributive, but what do you mean by distributive? Means if I do A multiplied by B plus C, then I can write it as A cross B plus A cross C. So this is distributed. I can distribute the vector A across the addition, right? So let us see some few cases. I'll clear this. These are the properties of a vector product. So now the magnitude of vector product, like the way we did for theta is equal to less than 90 and greater than 90, we'll do it for vector product also. Okay, magnitude of vector product will be max when sin theta is equal to, when sin theta is max, right, and maximum value of sin theta is 1. So when will it be 1? When theta is, right, when sine of 0 is 0, sine of 90 is 1, when theta is 90 degrees. This is when it will be maximum. So the magnitude of A cross B is maximum when theta is equal to 90 degrees, and then it will become equal to AB. Okay. Now what is the minimum condition? It will be minimum when sin theta will be minimum, and sin theta is minimum when theta is equal to 0 or 180 degrees, right? So that means A cross B minimum is when theta is equal to 0 degrees or 180 degrees, and this will become equal to 0. So the vectors are collinear or parallel, right? Theta can be 0 when they are parallel, right? The two vectors have to be parallel or called as collinear vectors. Then the cross product will be, the cross product of parallel vectors will be 0. Okay. Like for example, if we have two unit vectors, the unit cross product of two unit vectors is 0, and this is also the same for j cross j, and the same for k cross k, right? Because k is along k only, all these are parallel unit vectors. So the cross product of unit vectors is 0. Now let us consider another case. If we consider cross product of two vectors in unit vector notation, then we can write as A cross B, the unit vector notation. Okay, if you remember that, we have to take the projection this time. A cross B can be written as A of in the x I cap plus A in the y j cap cross B in the x I cap plus B in the y j cap. Okay. So then we can take the cross multiplication we can do. So you will get it as ax I cap multiplied by cross product of with b bx I cap, okay, plus ax I cap into by j cap plus ay j cap into bx I cap bx, this is bx, plus ay j cap into cross product with by j cap. Okay. Then the terms containing I and I, that means I and I, or j and j, where is j and j? This is j and j, will be 0. Right? Cross product of parallel vectors is 0. So therefore you will get Therefore you will get, this will cancel, this term will go and this term will go. So you will get Ax, what will you get here? And this product will be another third vector, right? I cross j will be k cap. I cross j, this I cross j will be k cap, and j cross I is ulta, will be downward, right? J cross I will be downwards, so then it will be minus k cap. So therefore A cross B can be written as Ax by, here this term will cancel, this term also will cancel, because it will become 0 here, because parallel unit vectors. J cross j will be a j cross j parallel vectors will be 0, cross product will be 0, because they are along the same line, they are parallel, right? Sin of 0 is 0. So here we have Ax into By, and I cross j will be k cap, plus you will have Ay, this term here, Ay Bx, and j cross I will be what? I was here, I and j, right? If z is upward, I cross j, and j cross I will be downward, right? Minus k cap. This is how you are supposed to write it down. So an alternate method of how to do it, let us see the alternate method. So let me clear this. If you have noted down, let me clear this. Let us consider two vectors. A is given as Ax I cap plus Ay j cap plus Az k cap, and B vector will be given as Bx I cap plus By j cap plus Bz k cap. So we can write this as A cross B. We can write this like this: I j k. This will be Ax, this will be Ay, and this will be Az. This will be Bx, this will be By, and this will be Bz. So now the I component. First for the I component. So you cover this, I component. It will be a cross product of Ay into Bz and then By into Az. Right? That will be the I component. So let me take it on another slide, I guess. We don't have sufficient place here. Let me take it on another slide. So it is given as A cross B is given as I j k. This will be Ax, Ay and Az, and this will be Bx, By and Bz. So the I component of this will be given as the I component. I component will be given as Ay cross Bz, basically Ay Bz, right, and By Az will be minus By Az. J component will be given as J cap, will cover J. What we'll do, we'll cover J and we multiply in the same fashion from here to here and from here to here. But however, J will be taken as negative. Okay, J will be taken as negative sign. Then you will directly multiply Ax Bz minus Bx Az. Here we will get a minus sign here. Okay, or you could have directly taken minus sign here, then you could have written directly as plus. This way we got it at minus here, but even without writing minus here, you need to take minus. Okay, now the k component, you cover k, you do the same fashion from here to here and from down to up. So you'll get k cap ax by minus bx ay. Okay, so this is how you're supposed to remember. So with this we found a way to find the cross product of two vectors. Okay, this is one of the method. This is another method to find the cross product. So I hope you are enjoying the session. Let us summarize about cross product. Summary cross. Summary cross product. A cross product is when you do a cross product of two vectors, you will get another vector. Another vector is the result, right? And the other vector is produced by the right hand thumb rule. Okay, then we have seen few cases. We have seen when for maxima, minima, we have seen when the maxima and minima is formed, right? So the I'll just write down here, the cross product is given as a cross b is equal to ab sin theta n cap. Okay, because it has direction also, it is a vector product, that's why we write n cap. Okay, the other aspect what we learned the right hand thumb rule to get the direction of the third vector. Then we saw that, what did we see? The vector product, the other vector, the third vector product, we can write this as a cross b. When is it maximum? It is maximum when theta, that means sine of 90, right? Sine of 90 is maximum, become AB. Another case we have seen a cross b when it is minimum. Minimum when theta is equal to 0. When theta is equal to 0, that time you will get a cross b will become 0 in fact. Okay. The other case when it is 0 is when theta is equal to 180 degrees, right? So basically these are parallel vectors. That's why we have seen that I cross I is equal to zeros. Likewise j cross j is also equal to 0. Likewise k cross k. Then we saw how to get the vector product of two vectors, right? Just to summarize the vector product, if we have two vectors, we draw a determinant like this, a I j k, write ax, ay, az, bx, by, bz. Then you always go in this fashion, from top to down and down to top, to multiply by covering this. Okay. So if you want to find the I cap, you will do ay into bz minus by into az. Now if you want to do j, you have to prefix j with a minus sign and then do ax into bz minus bx into az. So then you cover k plus k cap, you multiply az into by and ax into ay. Well, this was all about cross product of vectors. So we will come across a lot of problems for cross product and dot product as we go ahead and learn about other chapters of physics. Okay, so we are not going to cover more problems here, but we are going to now deep dive into physics. Now that we have completed the basic maths as part of class 10, we will deep dive into our next video, which is going to be basis of 1D motion. So stay tuned, subscribe, share to your friends so that they can make maximum benefit and learn physics in depth.